Last time we did up to dielectric constant. Let us try to understand what a dielectric medium is all about. So these materials, say this depending on the conductivity the base taraga, you classify the materials depending on conductivity. Materials are classified into three categories. One is conductor which can easily conduct electricity. One is insulator, and the conductivity which is in between that of conductors and insulators, that is known as semiconductors. Semiconductors to it. These are the classification of materials based on their conductivity. Well, what we are going to focus now for the time being is on these insulators. Okay, conductors are very common. These insulators are also very common, right? But for the time being, what you are interested is on insulator. Why I am focusing on insulator? Because these insulators, these insulators can be again classified according to their behavior. That is, one is pure insulator behavior laibama, and second behavior is dielectric behavior, or say dielectric substance. What differentiates between a pure insulator and that of dielectric behavior? Among the insulators in pure insulator behavior and mama gumba kari gumba moi singse, and dielectric behavior hai water gumba kari gumba ka ana glass gumba aduna sida kari khanar kadino have kanda. When you give these two materials within an electric field am apply to hai targari nang sida kedorni positively charged plate am laigani, negatively charged plate am laigani, and within this region you will have an external electric field E naught vector. Ko adu batagadi high electric field si manung sida, if you place a pure insulator just like wood, plastic, etc., it will remain being an insulator. Insulator ki behavior to tum chela laine ba. That is what you mean by a pure insulator. Right? However, in certain insulators, just like water, okay, what happens is inside this insulator the charge gets induced. Okay, that means these positive charges will induce negative charges near its end like this, and this negative plate will induce opposite charge on the another surface inside. So there arises a small electric field in opposite direction to that of the applied electric field. So this is denoted by EP vector, or you will say polarized electric field or induced electric field. This EP is the induced electric field, E naught is the external electric field applied. Then under this condition, this dielectric substance which is being kept here will behave like that of a metal or conductor. So this is the difference. For dielectric substances, when it is kept in the electric field, it will behave like a conductor, and pure insulators, even though when we place it inside the external electric field, it will not be conducting. Pure insulator the conducting charge separation. However, dielectric substance the charge induction and electric field generator. This is the difference. Then the process of the process of inducing the charges on certain insulators. Okay, that is when external electric field is applied. That is known as dielectric polarization. Okay, dielectric polarization. Then how will you define dielectric polarization? Is the process of inducing process हाइबी थवों हाइबनी क्रम थवों मधुदी के दवा material नत्रगा insulator अमगी मनुंगा induce electric field अमा थोन बगी phenomenon क्रम बकांडा charge separation थोला कांडा क्रम बकांडा थोला कदरिनो सिगी charge separation से when external electric field is applied, that is known as dielectric polarization. So let me define it properly. Dielectric polarization is the process of inducing electric field in the material when an external electric field is applied. This is what you mean by dielectric polarization. As I have told you, this E naught sina karino, E naught sina, this is external electric field applied. External electric field applied to external electric field. Then EP vector is nothing but it is the induced or polarized polarized electric field. Then let us see the directions of E naught vector and EP vector. As outside this material, E naught vector comes from left to right, that means it should be directed from left to right. But inside the material, inside the dielectric substance, let us see the direction of EP vector. EP vector will be directed from right to left. How is their directions? Their directions are opposite. Then if you want to find the resultant of these two electric fields, what will happen? You will just simply subtract. And this resultant put okay E naught vector minus EP vector la. So the net electric field, the net electric field, net hybrid resultant hybrid, this E vector, this will be nothing but E naught vector minus EP vector. And for dielectric substances, this E naught is always greater than this EP. Hybrid electric field say always exist non-zero value E naught EP electric field should be always some positive value. This is what happens in a dielectric material, and the process is known as dielectric polarization. However, when you consider about the conductors in electric field, in case of conductors in electric field, where lies the difference is that? The external electric field will be the same. Induced or polarized electric field will be the same. However, in case of the conductors, what arises, what condition arises is that this value of EP will increase until this E naught is equal to EP. Induced electric field is automatic saukalakani madudi ang apply to electric field to manera kaniyama. Managi target kitawni. Manavani E naught ka minus tauna target kay tarani E naught minus E naught kay tare. Kay tare manavani minus or the electric field becomes zero. That's why in Gauss theorem also you have found inside the conductor, even when it is placed inside an electric field, the electric field value inside the material, inside the conductor is always zero. Gauss theorem doesn't point to prove that way. Likewise, here in the case of dielectric polarization, in case of conductors also, what happens is that the value of E naught and EP will be the same, and when you subtract the resultant of these two, you will get 0. That's why electric field is always 0 inside an electric field for conductors. Yareko, asi concept may am clear or this is the origin of the capacitor ki my principle may am originate okay.